Hello everybody, this is Bassem who's joined the Graph, and I'm creating this series of video tutorials to help you get started with graph databases, the Apache TinkerPop ecosystem, and with the Gremlin traversal language. These videos are based on the Getting Started tutorial on the Apache TinkerPop website, the one you see on my screen right now. And in this video, I'm going to show you how to download the Gremlin Console, how to create an instance of the modern toy graph, and how to traverse this graph using the Gremlin traversal language. I will start by downloading the Gremlin console. To do that, I will go to the Apache TinkerPop website, tinkerpop.apache.org, and I will click this blue button, Gremlin Console. Then I will click this download link. I have the habit of unblocking the files that I download from a trusted source. Then I will unzip this file. It took a couple of minutes, but now it's done. I will now move this folder to my program files folder because it makes more sense to have it there. And I will open this folder. And now to start the Gremlin console, I will go to the bin folder. And because I'm on Windows, I will run this gremlin.bat file. On Linux, you will want to run gremlin.sh instead. Now it's time to write some code. I like to write my code in Notepad and then copy and paste into the Gremlin console. And then when I'm done, I'll share this text file, and the link to it will be in the video description. Let me start by resizing everything so it's nice and big. TinkerPop comes with a lightweight in-memory graph database server called TinkerGraph. TinkerGraph is an in-memory database, meaning that nothing is being persisted to the disk. Once you restart it, all the changes are lost. So this is not really something you can use in production, but it's very useful for testing and for learning the Gremlin traversal language. It also comes with toy graphs. Toy graphs are example graphs that you can quickly load and play with. They are often used as examples in the Gremlin tutorials. In this tutorial, we will use the modern toy graph. So to create an instance of the modern graph, we will say graph equals thinkerfactory dot create modern. And the code I'm writing here is Groovy code, and the reason I'm writing Groovy code is because this is what is expected by the Gremlin console. But you don't really need to be an expert on Groovy. Groovy is just a variation of Java. So if you're familiar with Java or any of the other C-based programming languages like C++ or C#, you'll be able to easily understand this Groovy code and write it. And by the way, there are Gremlin libraries for all the major programming languages like Java and C# and Python. So if you're writing your Gremlin traversal code in a C# application, you will see that your code, your C# code will look very much like the Groovy code you're seeing here that we're writing for the console. It's basically just chained function calls and arguments passed to these functions and assignments. Nothing that is too specific to any of the programming languages. The next step is creating the graph traversal source. The graph traversal source is needed to be able to manipulate and traverse the graph. It specifies things like the traversal strategy, for example, and it will be the entry point for all our Gremlin traversal codes. By convention, the traversal source is called G, so we will say G equal graph.traversal. And I will copy that and paste it in the Gremlin console, and we just created our traversal source. I will move to the next step. So the next step is getting all the vertices from the graph database. Well, we finally got to the part where we get to traverse the graph using the Gremlin traversal language. And before we do that, I think it's a good idea to take a look at this graph. So I have here a graphical representation of the modern toy graph. And you will see we will have 6 vertices in this graph. Vertices are sometimes called nodes, and these are these blue circles here. Some of the vertices represent person objects, other vertices represent software. And these vertices are connected with edges or relationships. Like a person creates software, that's a relation, and a person knows another person, this is another relation. And also there are IDs on each of the vertices in each of the relation. Like this person has the ID 1, and this created relation has the ID 9. And also, other than the ID, each vertex and each edge can have other properties. Like this person vertex, for example, it has a property name equal Marco and a property age equal 29. And not only vertices can have properties, but also edges can have properties. That this created edge or relation, it has a property weight equals 0.4 here. This tells you how much this person has contributed to this software. And there is also a property under knows relation. I guess how much person 1 knows person 2, that's the weight of the relation. Okay, so we mentioned the ID and the properties, and there is also the label. Maybe I mentioned it, but not explicitly enough. Each of these vertices, it has a label. Here, the label of this vertex is person. The label of this vertex is software. And relations or edges, they also have labels. Like the label of this edge is knows, and the label of this edge is created. So just to recap, we have vertices and we have edges. Both vertices and edges have IDs and labels and properties. Now back to our notepad. So the first traversal we want to do is getting all the vertices from this graph database. We said before that our entry point for any traversal is the graph traversal source, the G object. So we'd say G dot capital V, and this is a function to get all the vertices in the graph database. So I will copy that and I'll paste it into the Gremlin console. And we got 6 vertices, just as expected, because our graph has 6 vertices. Now let's move to the next traversal. So on the next traversal, we want to get the vertex with the ID 1. So this same v function that we used before, it can actually take an argument, which is the ID of the vertex we want to get. So I can say g dot capital V and pass the ID 1 to the function v. This will get us the vertex with ID 1. So we're supposed to get 1 vertex instead of 6, like the result of the previous traversal. I'll test that in the Gremlin console. And we got just 1 vertex with the ID 1, just as expected. In the next traversal, we want to get the value of the name property on the vertex with ID 1. So instead of getting the entire vertex with ID 1 like we did in the previous traversal, we just want the value of the name property from it. So I'll start by doing what we did before. I'll say g.v and pass 1, the ID 1. This will get us the vertex with the ID 1. And we want the value of the name property from this vertex. So to get that, I will say dot values And the values function takes an argument, a string argument, which is the name of the property. And the name of the property here is name. So g.v1 to get the vertex with ID 1, dot values name to get the value of the name property. Let's try this in the Gremlin console, see if it works. And it did, we got Marco. Is this the expected result? Yes, that's the vertex with ID 1 and the name property has a value of Marco. So we got exactly what we expected. Now the next traversal. It says start from the vertex with ID 1 and get the outgoing edges labeled nose. So to start from the vertex with ID 1, we will do what we did before, g.v1. And then to get the outgoing edges labeled nose, we will use another function called outE. And if I just call outE without passing any arguments, it will get me all the outgoing edges. But this is not what we want. We only want the outgoing edges labeled nose. So I will pass the string nose as an argument to this function. Let me help you picture this a little bit better. The first part of our traversal code, it says g.v1. This will be like placing a Gremlin traverser on the edge with ID 1. So let's imagine we have a Gremlin traverser placed on this vertex with ID 1. Then the second part of our traversal code, it says outE nose. This will move the Gremlin traverser to the outgoing edges that are going out of vertex 1 and labeled nose. We have two such edges. We have this edge right here, and we have another edge labeled nose. So the second part of our traversal code, it made the Gremlin jump from vertex 1 to the outgoing edges labeled nose, and now we have two Gremlin traversers. And this is the end of our traversal code. So these two traversers will return the result, the position where they are at right now, the two edges labeled nose. So let's test this in the console. And it did get us the two edges, edge with ID 7 and the other edge with ID 8. That's the edge with ID 7 with the Gremlin on it, and that's the edge with ID 8 with the other Gremlin on it. So that's exactly the result we expected. Okay, now the next traversal. It says get the names of the people vertex 1 knows, and we have a long version of this traversal, and we have a more concise version of this traversal. I will start with the long version. So to get the names of the people vertex 1 knows, we need to start from vertex 1. So I will do what we did before, g.v1. And again, let's try to picture this. I'll first delete these old gremlins from the previous traversal. And we just placed a gremlin on the vertex with ID 1. And we need to move it to the people that vertex 1 knows, like this person 2 and person 4. So to do that, I'll start by moving it to the edges, and from the edges, I will jump to the in vertex. So to go to the edge, we will do what we did before, .outE knows. This will split this gremlin into two gremlin for the two edges labeled nose. One will go here, and the other will go on the other edge labeled nose. But that's not enough this time, because we want to get to the other in vertex to be able to get this person's name. So to move the gremlin into the vertex, I will call the function in v, and this will move to these two gremlins to the in vertex. So this one will move here, and the other one will move to this in vertex. And still we're not done yet, because we don't want the vertex itself, we want the name of the person. So these two gremlins, each of them will need to get the name property value from the vertex it's on right now. And the function to do that is called values, and the argument is the property name, which is name. So each of these two gremlins will get the value of the name property from the vertex it is on right now. This should do, so let's test this query. Apparently I made a mistake. Oh, it is values, not value. So I need to correct the typo here. Try again, and it did get us the two names, Vadas and Josh. Let's check the graph. So this gremlin got the name Vadas, and this gremlin on this vertex got the names Josh. Exactly the result we expected. So let's move to the next query. Here we want to get the exact same result that we got from the previous traversal, but we want to do it in a more concise way. Still, we want the names of the people that vertex 1 knows. So we will start at vertex 1, g.v1. I will delete the old gremlins and place this gremlin on vertex 1. And instead of doing what we did before, going to the out edge and then going to the in vertex, maybe there is a more concise way to make the gremlin jump directly from the out vertex to the in vertex without passing by the edge, because we don't need anything from the edge. If we needed the weight, for example, of this relationship, it would have made sense to stop by the nose edge. But we don't need anything from the edge, so we want to jump to the in vertex directly. And there is a function for that. So instead of going out E nose and then in V, we can say out. We use the function out. And it takes an argument, which is the label of the edge. And this will move the gremlin directly to the in vertex. And it will be split into two gremlins because there are two nose relations. And these gremlins are now on person 2 and person 4. Now we need to get the names of these people. So we will use the values function and give it the property name. And again, what we did here, we replaced out E in V by the function out, which is used to jump from one vertex to another directly without passing by the edge. Let's test that. And we got the same two names, Vadas and Josh. In the next traversal, we want to get the names of the people vertex 1 knows who are over the age of 30. This is the same as the previous traversal, except we have a filter here. We only want the people whose age is above 30. So anyone who is 30 or less needs to be excluded. So we will start by going to vertex 1, g.v1. Let's visualize this on the graph. This will place a gremlin on vertex 1. And from vertex 1, we want to go to the people that person 1 knows. Person 1 knows person 2 and person 4. So to go to these two vertices, we will say out knows. And this will split this gremlin into two gremlins. One will go to person 4 and the other will go to person 2. And at this point, we want to filter because we want only the people whose age is more above 30. So Josh is above 30 and Vadas is 27, so less than 30. So we want to keep Josh and exclude Vadas based on the age property value. And to do that, I will use the has step. We'll say has, and this is a function that takes two arguments, or At least to overload, we will use here takes two arguments. The first argument is the property name, which is age, and the second argument is the predicate. In this case, greater than 30. And you may be wondering, it looks a little bit strange calling a function this way without an object name or a class name. And the reason we're able to do this is because this function is statically imported by the Gremlin console. You would normally need to use the class name, which is p, by the way. So you normally say p.gt. But because gt is statically imported, so you can use it without the class name. Just say gt30. And this has step should exclude the gremlin on vertices, should remove this gremlin. So I will delete it. And only this gremlin on Josh will remain. So the next step, we want the name of this person. So to get the name, we already saw this before. I'll use the values function, name. And this should get us the name of person 4, which is Josh. Let's test this in the console. And we got exactly what we expected, the name Josh. This was the last traversal in today's video. I will upload this text file somewhere and I'll put a link in the video description. Thank you so much for watching. This was my first video about graph databases and TinkerPop and Gremlin, but it won't be the last. So please stay tuned. Thank you so much and goodbye for now.